In this video, we'll continue our discussion of line integrals, trying to make sense out of these through an example. Okay, the temperature of a circular plate. So that plate, if you see, it's the circle, but it has that less than or equal to 1. That's a unit circle, but the whole plate. So I have it highlighted here because I've recorded this already. But that represents this whole plate that's down here. That's the whole plate, not the surface above. The temperature on that plate is represented by that surface above. So that's T. Represents the surface, the temperature, the surface above it. So if I pick any point down here in the plate, like right here, the surface would tell me the temperature of that point. What they're wanting is the average temperature as we go along the outside of our plate. So as you can tell, that red line there represents the temperatures on the outside of the plate. What we're doing is we're adding up. Remember, we're going to catch the temperature at this spot. We're going to catch the temperature at this spot back here, all these spots, we're going to catch it, and then we're going to add them up, and we're going to find the average of that using our line integral definition. So our definition requires a few things. I wrote it down here. It's from the last page. We need to put the function in terms of t, and we also need to define a path, take its derivative, and find its magnitude. Right, we want the path that goes outside of the circle, just stays on the rim. We just use the unit circle from trig. This is cosine of t, sine of t. Remember, those represent x and y. And then to get all the way around the circle on the outside, we go from 0 to 2 pi. That's just the unit circle. We're going to work our way up to the magnitude of the derivative. So we got to find the derivative, which is going to be negative sine t. Sine is cosine t. And then take its magnitude. We're going to get, let's just put it in there, sine squared t plus cosine squared t. That's 1. Square root is 1. This makes sense. We know that the length of the tangent vector of the unit circle is 1. We know that. All right, so we have that. We also need to put temperature in terms of x and y. So I'm going to replace x with cosine of t, y with sine of t, using the definition. And then I'm going to simplify because I'm going to have to take an integral of this. So I get cosine squared t plus 2 sine squared t. We can separate that to help us out. We got cosine squared t, nothing changes there. And then I'm just going to write 2 of these instead of writing 2 of it. So I'm just going to write them separately. The reason doing that, if you notice, that is a 1. So this is equal to 100 times 1 plus sine squared. We're going to take our integral of this, so I'm just going to use the reduction formula. I put it over to the right. It's been very helpful this semester. It's a good one to get down. Now, if I want to find the average temperature, we'll do average temp. There we go. Then it's the integral over c. We'll call this path c of our temperature function ds. But we know that that is the same thing as t from 0 to t 2 pi. I put my function I've made in terms of t inside. I also multiply by the magnitude of the derivative of the path, dt. All right, this is, as you can tell, that turned into an extremely easy integral. We can factor out the 100. And then we still have 1 plus sine squared t dt. Let's go ahead and integrate that. The integral of 1 is t. Then we use the reduction formula here. I got cosine of t, and then sine of 1 less of the power, that's just sine of t, over m, which was 2, for t equals 0 to t equals 2 pi. I want you to notice a few things. If I plug 2 pi or 0 into this term, you have to plug it into sine. Sine of 0 is 0, sine of 2 pi is 0. That term's just going to cancel out. This term is just, if I could plug 2 pi in it, but the 0 is going to cancel out. So really, we just have 100 times 2 pi, which is 200 pi. Now, they didn't give us any temperature measurement, me looking at. I may be overlooking it, but they didn't give me Fahrenheit or anything like that. So the average temp around that circle is 200 pi.